There is a star in the sky tonight that is going to explode. And when it does, it won't be a thing you just hear about in the news somewhere. You'll see it. Another point of light in the sky, so bright, it casts a shadow on the ground at midnight. So bright you can see it in broad daylight, burning right beside the midday sun. For months, almost everyone alive will get the chance to see it. A sight no one has seen for 400 years. You can find this star right now if you look up. Look for Orion the Hunter, the 3 bright stars that make up his belt. Follow that line all the way to his shoulder. The red one, that's the one. It's already dying. You could wake up tomorrow to a strange new light blazing up above you, an unexpected supernova in the sky. Or you could wait your whole life and never see it change at all. There is no way to know which. So the only real question is whether you'll be alive to see it. And the strangest part of this story is that when you finally do see it, if you do, you won't be watching it die. It will have already died, centuries ago. And what you would be looking at is light that traveled through the dark for 600 years to reach you. You'd be looking at a ghost. When that night finally comes, maybe tonight, maybe in 1,000 years, it will be the first news of the star's death. 600 years too late. So let's do something rare. Let's watch a giant star die. Slowly at first, and then faster than you can believe. We're going to count it down, from the first sign of trouble to its final second. And the closer we get to the end, the faster the star falls apart. Let's begin. Its name is Betelgeuse. It sits roughly 600 light years away in the constellation Orion, on the Hunter's shoulder. We call this kind of star a red supergiant, and for good reason. If you took Betelgeuse and put it where our sun is, its surface would stretch past the orbit of Mars. It would swallow Mercury, Venus, Mars, and Earth whole, and its edge would continue on toward the asteroid belt. Our sun would be a hopeless speck, lost somewhere deep inside it. If you could stand close to it and watch, you would see something that looks like it's barely holding itself together. The surface of Betelgeuse boils. The surface of our sun consists of millions of smaller cells, each one about the size of Texas. On the surface of Betelgeuse, each cell is larger than the entire orbit of Earth. Enormous, bubbling masses of gas that swell, then burst, then sink, then rise again. The star bulges, morphs in and out of shape, flickering and heaving all the time, like something that is finding it harder and harder to stay whole. The star is enormous, and it's running out of time. In the winter of 2019, something strange happened. Betelgeuse began to dim. Any observer familiar with the night sky could easily see that it was becoming fainter and fainter by the day. It was no longer one of the brightest points of light in the sky, and for a few months, people wondered whether we were watching the beginning of its end. The actual explanation was something stranger than that. The star had ejected an enormous cloud of dust from its own surface and flung it out into space. The cloud hung there for a while, veiling its own light, so it appeared dim from Earth. You were watching Betelgeuse heave and sigh, the tired breathing of a star running out of ways to hold itself up. But the trembling we can see from Earth is just a symptom. The real story is happening far below the surface, in the core. And it isn't a slow decline at all. It's a countdown. A clock that has been ticking for millions of years and is now nearly at zero. Let's go inside and watch the last of it. Every star is a battleground, a war between two forces. Gravity, always pulling inward, trying to crush the star into nothingness. And nuclear fusion, the fire at the core, always pushing outward, resisting. For most of a star's life, the two are balanced. And that balance is exactly what a star is. But fusion needs fuel, and a star only has so much of it. The burning always starts with hydrogen, the lightest and most plentiful gas in the universe. Betelgeuse burned through its hydrogen long ago, fusing it into helium. That first stage lasted millions of years. When the hydrogen ran out, it started burning the helium and turning it into carbon. This stage was much shorter, a few 100,000 years maybe. And this is the pattern that will kill it. Every new element that shows up burns hotter and faster, buying the star less time than the one before it. After helium comes carbon. The carbon burning stage in a star like this only lasts around 1,000 years. For a star that has already lived for 10 million. Then carbon gives way to neon, which burns for maybe a few years, followed by oxygen, burning for a matter of months, and then silicon, lasting mere days. It's extraordinary when you think about it. A star burns hydrogen for millions of years, thinking it has all the time in the world. Then the hydrogen runs out, and with every subsequent phase, the star burns brighter and faster the closer it gets to the end. It's almost as if the star can feel death coming, and so it burns through its last reserves in a rising panic, reaching for anything that will keep it standing for just one more day. After silicon, there is nothing left that can save it. Because silicon turns into iron. For its entire life, fusion has been the thing keeping the star alive. Every time the core fuses a light element into a heavier one, it releases energy, the outward push that holds gravity back. Hydrogen becomes helium, helium becomes carbon, and so it goes. Every step gives something back. Iron is where that stops. It takes more energy to make than it produces. When a star tries to burn iron, it gets nothing back. For the first time in the star's life, its fire does not pay for itself. Trying to fuse iron into any element beyond it would be a losing proposition for the star. So when the silicon in the core finishes burning, and what is left behind is a growing ball of iron, the star has reached the end of everything it can do. There is no next fuel to look forward to. There is no tomorrow. The star fills up with ash it cannot burn, and the war the star has been fighting for 10 million years is lost. The star's heart is now a sphere of iron, something like a sun's worth of mass, packed into a space no larger than a planet. The fire that held it up for 10 million years is gone. All that holds it now is the raw resistance of matter that cannot be squeezed any tighter. And then even that gives way. The end, when it comes, is almost too fast to describe. The outward push of fusion switches off, and gravity, which has waited patiently for 10 million years, finally takes everything it wanted, all at once. The core, a sun's worth of mass crushed into something the size of a planet, collapses in on itself. In a quarter of a second, the core falls inward at nearly a quarter of the speed of light. Then, for the briefest possible moment, something stops it. The matter at the center is crushed as tightly as matter can physically be crushed, and it refuses to go any further. The infalling matter can only rebound, sending a shock wave rippling back up through the star's body. That shock wave is the thing that should tear the star apart, but most of the time, it can't. Because the star is still falling. Even as the shock wave races away from the center, the outer layers of the star are falling toward the core. So the shock wave is actually pushing against material that's rushing in the opposite direction. And it can't do that for long. It can only push so hard before all that inrushing material pushes back down on the shock wave, stopping its expansion, until the entire weight of the collapsing star pushes down on the wave, essentially smushing it. And it loses. It runs out of force and grinds to a halt, the whole weight of the collapsing star pressing down on top of it. For a moment, the entire explosion hangs there, undecided. And in as many as 1 in 4 of these deaths, this is where the story ends. The star completes its collapse, and where a giant used to be, there is only silence and a newly born black hole. But Betelgeuse is saved by something unexpected. When the core collapses, it flings out a flood of tiny, ghostly particles called neutrinos. Most of them stream right through the star, as though it isn't even there. But a tiny fraction of them slam right into that stalled shockwave from behind, giving it the boost it needs to continue expanding. The energy from that tiny contingent of neutrinos is all that shockwave needs to escape the star's gravity and carry material away from its core into a fiery explosion. And it's enough. The wave catches, surges, and wins, ripping outward through the star and blowing it apart from the inside. This is the moment Betelgeuse dies. The core has collapsed, the heart has stopped beating, and the shockwave that will rip the star apart from the inside out is already on its way. But no light from the explosion will arrive at the surface, the part we can see from Earth, for hours. The star is so vast that news of its own death cannot cross it fast enough. Betelgeuse will hang in our sky exactly as it always has, still shining out of habit. You would have no way of knowing, except for one thing. Neutrinos. The same flood of ghostly particles that saved the shockwave, born the instant the core collapsed. They are the one thing that gives the secret away. Because they leave first. While the shockwave is still fighting its way out through millions of miles of star, the neutrinos are already gone, streaming out through the whole body of the dying giant, as though it were empty space, racing into the dark at nearly the speed of light. They escape hours before the light of the explosion can claw its way to the surface. The blaze you will eventually see, the blazing star that will outshine all the others and burn in the daytime sky for months, is only a fraction of what has escaped the dying star. It's the leftovers. When a star like this dies, almost all of its energy, nearly 99% of it in fact, escapes in that first unseen torrent of neutrinos in a matter of seconds. The light that will one day stop you in your tracks in the middle of the street is only the faint remainder of a silent explosion that is already over. And we have been waiting for it. Deep underground, in tanks of water and liquid the size of buildings, there are detectors built for precisely this moment. They are wired together into a single system that spans the globe, an early warning network whose only job is to notice the instant a star dies in our galaxy. As soon as this happens, it sends an automatic alert. And here's the thing. It has never gone off. The last supernova seen in our own galaxy happened in 1604, before the machines or the science, or any of us. The alarm is armed, and it's silent, quietly waiting for a moment just like the one Betelgeuse will one day give us. When that day comes, and the neutrinos from Betelgeuse arrive, the alarm will go off, and in the hours that follow, every astronomer in the world will know that the star is dead, while the star itself still hangs in the sky. For a few hours, we will know a secret the sky hasn't told. Telescopes will swing toward Orion's shoulder, and the world will hold its breath and wait for news in the sky of the death of a star that is already gone. Betelgeuse is roughly 600 light years away. That means the light you see from it tonight is around 600 years old. It left the star during the Middle Ages, and it only just reached your eyes. We are not watching Betelgeuse as it is. We are watching it as it was 6 centuries ago. And so, if Betelgeuse exploded at any point in the last 640 years, if it died while cathedrals were being built, or while empires were rising and falling, you would have no idea. The light from its final moments would still be on its way. It would not be here yet. The odds that it has already happened are small, very small, but not zero. So the red star you can look up and find tonight, the one in Orion's shoulder, there's a real chance it's not there anymore. It could be long gone. So let's say it happens, tonight or 10,000 years from now. The neutrinos flood the Earth, the warning goes out, and a few hours later, Betelgeuse's light finally reaches us. Here is what you would actually see. There will be a first flash, the shock wave finally breaking through the surface of the star. You'd see something like a sudden burst of light that quickly rises in intensity and then falls back down within minutes. A false start, you might call it. And then the real rise begins. Night after night, the star will get brighter. Brighter than the planets. Brighter than anything you've ever seen in the night sky. At its peak, it will shine at nearly half the brightness of the full moon. But where the moon spreads its light across a wide, soft disk, Betelgeuse will concentrate all of it into a single blazing point, resulting in the appearance of a blinding white star right in the middle of the sky, a point of light so concentrated it will be almost painful to look at directly. You will live under this star. For 2 or 3 months, there will be a second light in the sky. When you walk outside at night, you'll cast a shadow on the ground, and it won't be the moon's fault. The culprit will be a single dying star 600 light years away. In the daytime, on a sunny day with clear blue skies, you'll look up and still be able to see it. A second star burning in the blue. Almost everyone alive will get the chance to see it. They will look up and see the same new star for months, wherever they are in the world. It will probably be the most watched, most photographed event of its kind in the history of our species. The last time we saw a star die in our own galaxy was in the year 1604. There were no telescopes yet. No one understood what a star really was. They watched it in awe and in fear. Then it faded away. No one has seen anything like it since. But you might. And if you do, you'll know exactly what it is. Betelgeuse will shine for months, and then one day, it will start to wave goodbye. Slowly, night by night, it will begin to fade. The constellation of Orion will be broken. The red star that has always marked the hunter's shoulder will slowly fade to black, and the pattern that our ancestors named will be changed forever in the course of a single season. And just like that, the star we once knew will have gone, not gently, into that good night. When the last light fades and the show is over, Betelgeuse will not entirely be gone. At the center, where the core collapsed, something will remain. A small, impossibly dense remnant of a fallen giant. Perhaps a neutron star, a corpse the size of a city where its heart used to be. Or perhaps something darker, a black hole. Something will remain. The ghostly remnants of a star that stretched past the orbit of Mars, now little more than a barely there speck, small enough to fit inside a city. The truth is, it probably won't happen in your lifetime, or mine. The odds are it has either tens of thousands of years left, or it died centuries ago, and its light just hasn't reached us yet. Either way, you will probably never see it go out. The most likely scenario is that Betelgeuse will just hang there, exactly as it looks tonight, for every year that you have left. Find it when you can. The red star in the hunter's shoulder. Stare at it. You won't know if what you're looking at is really there or already gone. It might still be burning, with ages left ahead of it, or long since dead, and you are looking at nothing but old light. You can't know. But then, you never really do. Every star you've ever seen is a message from the past, still arriving. Some of those stars are already gone. You just can't tell which. That's the strange thing about looking up. You don't get to see things as they are, only as they were. So Beetlejuice will keep its secret. And you'll keep looking anyway. You always do.